In today's video, I want to talk about finding the greatest common factor, or the GCF, of two numbers. Or really, we'll talk about two monomials, but just two things. How can I find the greatest common factor between two things? Well, what if I gave you two numbers like, I don't know, 12 and 18? Well, the greatest common factor between those numbers is the largest number that divides both. Both things, right? Both terms. The largest number that divides both of these things. So for 12 and 18, what's the biggest number that will divide either of them? Maybe you have an idea, maybe you don't. But the nice thing is you can always try. So here's, I kind of like to think of this, we call these factor trees. So maybe you can't think of the largest number, but you could think of a number that divides 12 and 18. Maybe you just think 2. I know 2 divides 12 and 18. So 2 divides 12, and 12 divided by 2 is 6. Okay? And 2 divides 18, right? And 18 divided by 2 is 9. Okay, well, I see that 2 is a common factor, but maybe there's more. So we need to find, is there a common factor between, so I don't know. Let's pick out 2, because we know that 2, this is going to be part of my greatest common factor because it's common in both of these. But what about 6 and 9? Because we can keep going. I know I talk about inception a lot, but it really is like inception, right? This is factorception right now. I'm going even deeper into my factoring. So 9, well, what divides 9 and 6? Well, 3, right? 3 times 2 is 6, and 3 times 3 is 9. So we have another common factor here in 3, right? There's 1, 3 in each of these. And maybe it's helpful for you to cross out the 6 and the 9, because we're really just talking about now 12 is 2 times 3 times 2 equals 12, and 18 is 2 times 3 times 3. And common to both of those is the 2 and the 3. So what's 2 times 3? Well, that's 6. So 6 is my greatest common factor. How can I check that? Well, let's divide both 12 and 18 by 6. 12 divided by 6, maybe an aside over here. 12 divided by 6 is 2. 18 divided by 6 is 3. These are both what we call prime numbers, right? Or numbers, and they're they have no common factors between them, right? 2 and 3, there's nothing I can divide 2 by that will give me a whole number that I can also divide 3 by that would give me a whole number other than 1, right? So my greatest common factor is 6. So the GCF, I would write the GCF of 12 and 18 is 6. Now, what does that look like when we start to get a little crazy with it? What does that look like when we start to get a little crazy with this? Let me give you something like 6x squared y, and maybe, what if I did, yeah, sure, 6x squared y, why not? And 24x y squared. Okay, so now I'm looking for the largest thing that can divide both. Here's how I think about it. I think about this in 3 different parts. First, I want to look at what is the GCF of 6 and 24. Then, and this is like terms, right? I want to find my like terms and find the common factor between all my like terms. So then I'd ask, well, what's the common factor between x squared and x? What's the greatest common factor between those two? And then what's the greatest common factor between y and y squared? Okay, so the greatest number that divides both 6 and 24. Well, in this case, again, we could do the factor tree, right? I see that this is divisible by 2 and 3, this is divisible by 2 and 3, but these are actually both divisible by 6, right? 6 divided by 6 is 1, that's okay. 24 divided by 6 is 4, and that's as far down as I can go. That's the greatest common factor, because 1, the only thing I can divide by 1 by is itself, right? So this is as far down as I can go. Okay, what about x squared and x? What can I divide x squared by that I can also divide x by? Well, if we did a factor tree here with x squared would be x times x. So I do have a common factor in between these two, right? It's just x. X divided by x is 1. X squared divided by x is x. And that's as far as we can go. So the greatest common factor here is x. In the same way, if I'm looking at y and y squared, well, what the greatest common factor between y and y squared, again, if I did a factor tree for y, well, this would be y times y. So the greatest common factor between y and y squared is y. So then my greatest common factor between 6x squared y and 24xy squared, the GCF of 6x squared y and 24xy squared is 6xy, because 6xy divides both of these, and we can check that. So to check my work, sure. So 6x squared y divided by 6xy, right? Y divided by y is 1. X squared divided by x is x. And 6 divided by 6 is 1. So I can divide this, right? That equals x. I don't end up with a decimal or a fraction, and that's what I want. Okay, in the same way, 24xy squared divided by 6xy. Y squared divided by y is y. X divided by x is 1. 24 divided by 6 is 4. So I'm left with 4 times y, right? And these aren't the same. They're not supposed to be the same. They just have to be whole numbers, not fractions, right? And that's exactly what we got. Okay, so GCF, find the largest number that can divide each term. And when you have something that has both constants like 6 and variables like x squared, you need to find what the greatest thing that divides each like term. 6 divides 6 and 24, x divides x squared and x, y divides y and y squared. So the greatest common factor is the combination of those, 6xy. Hope that was helpful. I'll see you in the next video for some more factoring.